Let's say we have some solid sodium chloride, so some salt, and that right there is supposed to be our pile of salt. And we're going to put our salt into some water. So we have a beaker containing H2O. The sodium chloride is going to dissolve in the water. So the sodium chloride is our solute, and the water will be our solvent. So this is the process of dissolution. And if you look more closely at sodium chloride, right, solid sodium chloride is an ionic crystal. And so it's held together by the ionic bonds, right? So the sodium cation, right, with a positive charge is attracted to the chloride anion with a negative charge. And so that's holding together our ionic crystal. When you put the solid sodium chloride into water, remember, water is a polar molecule. The oxygen is more electronegative than the hydrogens here. So the oxygen gets a partial negative charge, and these hydrogens get a partial positive charge. So we have a polar molecule here. And the negative charge on the oxygen is going to interact with the positive charge on the sodium, right? Opposite charges attract. So we have one water molecule here attracted to this sodium cation, and this water molecule would do the same, right? So partial negative charge, right, attracted to the positive charge on the sodium. And so the water molecules are going to pull off the sodium cations and eventually give you this situation over here, right? So we have the partial negative oxygens, right? Partial negative oxygens are going to interact with the sodium cation, right? So the water is a dipole and the sodium cation is an ion. So we could call this an ion-dipole interaction. And so the water molecules break the ionic bonds, pull off the sodium cation, surround the sodium cation, and so we call this process hydration. So this is the process of hydration, right, where the ion is surrounded and stabilized by a shell of our solvent molecules. The same thing would happen with the chloride anion. So right up here, the chloride anion is negatively charged, but this time the negative charge would be attracted to the positive part of our polar molecule, right? So the oxygen is partially negative, and this hydrogen here will be partially positive. And so opposite charges attract. The positive charge is going to interact with the negative charge, right? Same for this molecule of water, partially positive hydrogen. And once again, right, this interaction is going to pull off that chloride anion and move it into solution. So we have our partial positive hydrogens, right, interacting with our negatively charged chloride anions here. So once again, we get ion-dipole interactions. And the chloride anion is surrounded by our water molecules. So once again, the process of hydration. So the end result is each sodium cation is surrounded by water molecules, and each chloride anion is surrounded by water molecules. So the sodium chloride has dissolved in water. We formed a solution, an aqueous solution of sodium chloride. And the way that you see that written, right, you would write, here we have solid sodium chloride, which we put into water, our solvent, right, and the water molecules surrounded our ions. So now we have sodium ions in solution. So we write an AQ here for aqueous sodium ions. And we have chloride anions also in solution. So we write an AQ here. So we have an aqueous solution of sodium chloride. The sodium chloride has dissolved in water. Now let's say we have one beaker that contains a solution of NaCl. So an aqueous solution of NaCl has sodium cations in solution and chloride anions in solution. And let's say we have another beaker that contains a solution of silver nitrate, which is AgNO3. So an aqueous solution of silver nitrate means we have silver cations in solution, Ag+, and nitrate anions, NO3-. And now let's say we add the contents of one beaker to the other beaker. So let's pour the contents of, let's say, this beaker into this beaker. So we're combining our two solutions. So we would notice a few things. We would notice the volume to increase, obviously, since we're pouring the contents of one into the other. And we would also notice a white solid form. So a white solid is going to form down here. And that white solid forms when the silver cations interact with the chloride anions. So we get a solid forming that is silver chloride, AgCl. So we would write AgCl here. We put a subscript S indicating that a solid formed. This solid is called a precipitate. And this solid spontaneously falls out of solution. So this is the process of precipitation, which is the opposite of dissolution. In dissolution, we put a solid into water and we formed ions. Right? In precipitation, the ions come together to form a solid, and that solid spontaneously falls out of solution. So silver chloride is our precipitate. Right, we would still have some ions in solution. We would still have sodium cations and nitrate anions. So in here we would have sodium cations in solution and nitrate anions in solution. So we could add them into here. We could say NaNO3, right? So aqueous, meaning those ions are present in solution. Let's look in more detail about what's happening with the formation of our precipitate. Right, we know that we had silver cations in solution, right? So here's our silver cation over here, and we know that this ion is being surrounded by water molecules in the process of hydration, right? So these oxygens are partially negative right here, and since opposites attract, right, there's a force, right, that's holding that ion in our solution, right? The forces of hydration. Same thing for the chloride anion, right? The partial positive charge on the hydrogen, opposite charges attract, right? And so those water molecules are stabilizing the chloride anion in solution. But when we pour those two solutions together, right, we form our precipitate. We form silver chloride, right? We form this ionic crystal down here. And once again, opposite charges attract. So the positively charged silver cation is attracted to the negatively charged chloride anion here. And since we notice this solid to form, the electrostatic attractions of our ionic crystal must be stronger than the forces of hydration. So this chloride anion would move into here, right? And then this silver cation would move into here. So the ions come out of solution and a precipitate spontaneously forms. So we form our solid silver chloride. This is one way to represent what's going on here. We could have also drawn out all of the ions, right? So instead of writing that, another way to represent what's happening would be to say a solution of sodium chloride would be sodium cations in solution, right? So we write our sodium cations here. Chloride anions, so Cl minus. All right, we added to that our solution of silver nitrate, which had silver ions in solution, so Ag+, and nitrate anions, so NO3-. And we saw a precipitate form, right? So we formed AgCl, which is our solid. So we write AgCl here, which is our precipitate. And then we also had sodium cations and nitrate anions. So we had sodium cations, Na+, and we had nitrate anions, NO3-. And so that's a lot of writing, right? So either one tells you the same amount of information. This one down here just shows you all of the ions. And really only some of the ions are reacting, right? The silver cation and the chloride anion are coming together to form silver chloride. So we could write a net ionic equation showing what's happening to form our precipitate. We could show the silver cations here, Ag+. So we could show our silver cations and our chloride anions combining to form our precipitate, AgCl. Right? So this is the net ionic equation. And this is the net ionic equation because some of our ions aren't taking part in this reaction, right? They're just observing what's happening. This sodium cation, right, is on the left side. It's also on the right side, and it's an ion in solution. And same thing with the nitrate anion. It's over here on the left side as an ion in solution. It's over here on the right side as an ion in solution. So the sodium cation and the nitrate anion are called spectator ions. These are called spectator ions because they're not taking part in what's happening, right? They're just watching. They're watching as the silver chloride precipitates out of solution. So that's why we call them spectator ions. So this is the idea of precipitation.